continuity of graphs. And from algebra, a graph is continuous if you can put your pencil on the graph and if you can trace the entire graph without removing your pencil from the paper. So this first graph is a continuous graph because I can put my pencil on the graph and I can trace the entire graph without removing the pencil from the paper. B, I'm going to blow this up slightly. B actually has a hole in it, so I can trace the graph to a point, and that's called a point of discontinuity. I have to remove my pencil from the graph and then put it back on, and I can trace the graph. Right, so this has a point of discontinuity. For my last example, this is just a discontinuous graph, right? Because I can trace half of the graph, and then I take my pencil off and I put it back on, and I can retrace the other half of the graph. Now, in order to determine the intervals of continuity, those are just the intervals in which I can trace my graph without taking the pencil off the paper. So if I take a look at this first one, the interval of continuity is actually going to be the domain, and that's true for all of these. So negative infinity to positive infinity, right? I can trace that graph over the entire domain. If I look at my second graph, it actually has a hole in it, so I have to account for that hole. So I can trace the graph from negative infinity to 3. Then I have to take my pencil off of the paper at 3. And I can put it back on at 3. So I'm going to use union 3 to infinity. All right. And then for my last graph, the interval of continuity, which is nothing more than the domain. So I can trace this graph from negative infinity to negative 2. And then I have to take my pencil off of the paper, put it back on at negative 2, and I can continue to trace the graph.